Thanks for having me on. Ayal Yogev, the CEO and co-founder of Anjuna.
Wonderful. And I'm Marshall Kirkpatrick. Thanks for taking this time to meet with us.
Yeah, thanks for having me.
So, Ayul, would you please tell us about some common problems, some stories, if you will, of organizations, things that they wanted to do but were blocked by data security and privacy concerns?
Yeah, so let me start at a high level and then I'll kind of go into some specific customer examples. At a very, very high level, in many cases you have situations where you have the data, you have the model or the code you want to run that data in, and you have the infrastructure it's running on. And every time you have more than one entity owning all of that, meaning two companies want to share data with each other, or a company wants to use its data to run in somebody else's model, or you want to take your data or model or code and run it in the public cloud, which is somebody else's infrastructure, you run into a privacy or a security issue. And that's exactly what confidential computing solves. That's exactly what we solve as a company. Let me give you a couple of examples. One is we have a customer on the healthcare side, and they have obviously patient data and what they want to do is they want to leverage the new AI models. There's a bunch of companies offering AI models to do things like early pregnancy detection or early cancer detection. And they want to run their data inside of these models to help their patients essentially, and to obviously improve kind of how they plan. The problem is that data is very regulated. It's regulated data. They can't run patient data as somebody else's model because of the privacy and security issue. And what confidential computing does, and what we essentially enable for them, is the ability to take that data and run somebody else's model. Another good example is we have one of the top 10 banks that was using us to. They essentially have this mainframe model. That's this mainframe that essentially holds a lot of the data. They run it to the problem that they ran into is. They build a mobile user app, and what happens is every time a user wants to do something on their mobile app, it ends up having to go back to the mainframe. And the mainframe essentially became a bottleneck because everything had to go to the mainframe. And the best way to do this is you want to take something like this and put it on the cloud. We want to have almost like like this sort of database that exists on the cloud that allows you to scale up and down to store these things and then go back to the mainframe once a day when you need to do so. And the cloud is perfect for that because it can scale up and down, right? After payday, you have millions of people coming in to view their bank account, so you want to scale up. Middle of the night, very few people come in, so you want to scale it down. Problem they ran into is privacy and security, because taking that sensitive data and putting it in the cloud was something that their internal team said is a no-go. And that's where confidential computing could help run that in the cloud and basically solve that bottleneck problem with the mainframe.
So what kind of positive business outcomes and perhaps new technical capabilities are enabled by confidential computing?
Yeah, it's a great question. Again, let me start kind of at a high level and then go deeper. My entire career was security. I've been in enterprise security for the last 25 years, and I would say that the best security solutions were always enablers. And you see this in the real world with things like banks, right? If you couldn't trust your bank with your money, the banking industry wouldn't exist, right? You need that security and trust to do something. And we've definitely seen in the digital world with, again, just a couple of examples, the firewall. The reason why the firewall became so successful is that it allowed organizations to connect their internal networks to the internet for the first time. And there's obviously an enormous amount of value that was unlocked by connecting to the internet, but companies wouldn't do that before they had the right security to do that. Another great example in that regard is HTTPS. I'm sure you still remember a time where we couldn't sit in an airport and connect to our bank account or connect to our corporate email or at a Starbucks and do that. And that's not an issue anymore. I don't know if I'm sure you've seen, like, you can sit in an airport and connect to anything, no problem. Security is what enabled that. The fact that everything is encrypted from your browser all the way to the server is what essentially opened that up. And confidential computing is that next big enabler. And I thought about, I knew it was going to be an enabler, but kind of how to talk about what it enables. And I think the best way to describe it is collaboration. As I mentioned, every time you have two entities that want to work together, either sharing data or using somebody else's model on that data, or using a separate somebody else's infrastructure, this is what this enables, where you just don't have to think about it. Nobody has access to your data. Nobody has access to your code. You can just do that, and that's what it enables. And again, it's those use cases. It's essentially being able to leverage the cloud, being able to leverage AI. The AI is kind of most of what we're seeing now, at least with our customers. And maybe the way to think about this is we've seen companies like McKinsey and Gartner telling companies data is the new oil for the last 20 years. And they've been collecting that data to say, okay, we'll do something amazing with that data, but it hasn't really fully realized its potential. And then when OpenAI came out with their model, everybody's eyes, sort of opened. Okay, now there's something we can do with that data. And as they're starting to go down that path, they realize they're running into a security and privacy issue because that data is sensitive in many cases. And that's what's confidential computing enabling now for a lot of organizations.
Mm-hmm, mm-hmm. So it's unlocking access to the new AI models, and it's enabling this multi-party processing.
Right.
And I imagine those could be enjoyed both as distinct benefits, but also complementary in some cases. Are you familiar with any stories yet of multi-party processing plus AI in a confidential computing context?
Yeah, actually, one of the things we're let me just be careful on kind of the names that I use. They're actually going to be talking to us publicly on stage. So I think I can name them is Royal Bank of Canada, and what they're essentially using us for is they have a lot of vendors in Canada they're working for their for their loyalty programs, or to do things like when you get your so let's say credit card points, you can get whatever first, like $5 off of Starbucks if you want to use that, things like that, which is not personal to you specifically, right? Sort of this very, very general thing. And yeah, they can see that maybe you bought something on Starbucks, but they can't really see the data. And obviously Starbucks doesn't want to share that data with anybody, what specifically you bought. Confidential computing opens that up, where you can, without actually sharing the data, you can create with much, much more targeted offers in terms of what you can do with that without actually sharing, the data with each other, sharing the model. And I think we're going to see this in advertising is one piece that we're going to see this, because essentially the companies that own the data don't want to share it with the advertisers, and the advertisers don't want to necessarily share it with the companies that own the data, why they're targeting specific people, and this allows them to collaborate on that. Another really great example that we're seeing is on manufacturing. We have manufacturing customers that essentially they're manufacturing, they're running things for their customers, and sometimes they want to improve their processes, right? They want to get data on what is the percentage of failure rate, for example. What are the percentage of failures, as an example, where they can improve their process. But the problem is that the companies that are running on top of them don't want to share that data, because this, for example, can impact the share price, right? This is very sensitive financial information, and this allows them to get the data that they need to improve their process without getting the data that their customers don't want to share with them.
From your experience, these kinds of real trailblazing early adopter champion institutions like the Royal Bank of Canada, for example, every wave of innovation really needs some people and some organizations willing to invest in that kind of use case. Can you tell us a little bit about what you have seen across your career and now in terms of what's in it for them? And can you offer any words of encouragement for other would-be champions to step up and blaze those kinds of trails?
Yeah. So I agree that I think what I've seen in my career, specifically in security, is that the early adopters tend to be sort of the large, more regulated organizations, mostly because they're targets, right? Banks are targets, right? Governments are targets. Healthcare is a target, as we've seen a lot of the breaches that recently happened. Manufacturing is a target. We've seen these kind of large, oil and gas is a target. We've seen these organizations that are targets. It's funny, in other industries, they're not the ones you think about as early adopters, right? Banks are not an early adopter for almost any industry. They are for security. And that's to some extent what we're seeing. And part of the reason why we're seeing them as early adopters is, one, obviously they're targets, but also the amount of value that they can unlock with the right enablement of security. But basically their decision tree is risk management, right? If this is too risky, we're just not going to do it. And if they find a way to reduce the risk and do it, then they go down that path. And that's what confidential computing provides them.
I imagine in both adoption of confidential computing and in a meta sense of then and being able to adopt all kinds of other practices now in a secure context.
100%. Again, leverage the cloud more, leverage AI more, do collaboration that they couldn't do before. It just opens up the door for them to do things that they have always wanted to do, but just the risk profile was too high without a solution like confidential computing.
Amazing. So will you tell us what's your current What's changing right now about your strategy? I'm sure there's a lot of things that have held true across your career and in different contexts, but standing in the confidential computing industry now in 2024, what's new and changing in your mind strategically about how you want to engage with this market?
Yeah, again, the really big change that happened in the last year, I would say, was around AI, and it's probably true for us, but everybody else. But this just unlocked a huge amount of demand for confidential computing because of what I said, because of all that data that exists. People now want to leverage it with AI, and then they got stuck. And this is so top of mind for so many organizations that we're just seeing a wave of people coming in to say, okay, how can we go leverage our data, or either collaborate on that data? And again, there's a bunch of things you can think of. How can you underwrite insurance policies if you can share data across multiple companies, where before it's unheard of, but confidential computing opens the door to that. Think about anti-fraud use cases where you have financial organizations and you have people committing fraud, and then they don't necessarily focus on one financial institution. They spread, they work with a bunch of them, but it's very hard to share that data because it's sensitive data, and there's a lot of regulations about how that data is being shared. With confidential computing, you can do that. Data sovereignty is another one that we're seeing. And I think it was talked about in the conference on stage, the panel by Mark Russinovich, the CTO of Azure, where they're basically seeing the way data sovereignty is done right now is data can't leave the country, which kind of makes sense, but it's a very weak way to really protect the data. If you can do that using confidential computing, one, you have much better protection, but also you can extend that protection across border, right? You can have a little piece of, Switzerland in the US that only Swiss citizens have access to. So it gives you the flexibility, but also much, much better security.
So let me conclude by asking you, in big picture terms, where do you see the industry going right now, and where do you think that it ought to go?
Yeah. I think where it's eventually going is that confidential computing will become computing. And the reason I say that is every time you had a security solution that had two characteristics, which was ease of use and low to no performance impact, it just became the default. And again, we talked about HTTPS. The reason why HTTPS is now across everything, again, you can't open a personal blog and not see HTTPS. You go to a news website, you go to CNN.com, it's going to be HTTPS. There's nothing sensitive on a news website, right? It's public information, but why wouldn't you turn it on if it's a checkbox you turn on and you get security and you get confidentiality? Again, disk encryption is another great example where 10 years ago, no disk was encrypted. Today, you buy a laptop, the disk is going to be encrypted by default. And it's these two characteristics. Again, firewall, another great example where, it started with the large banks connecting their internal network to the internet. But if you're at home today, you're probably crazy if you connect to the internet without a firewall. And that's where confidential computing is going to go. It has these two characteristics. The performance impact is extremely low because the hardware vendors are doing all the heavy lifting of the encryption. So the performance impact is very low, and it's only continuing to go down with new versions that come out. And then what we do with Anjuna is making it super simple to use. We can take any workload, run it on top of any confidential computing environment with no changes, completely from the outside. And when you have these two characteristics, I think it's just going to be confidential computing across the board. And if you have a minute, where I think this is going to lead us to is once everything is running in confidential computing, it means that no data is ever exposed. The data is never exposed to anybody, regardless of what level of access they have to the systems. So then you can go and get rid of a lot of the security stack that you have today. For example, do you need a firewall anymore? Do you need TLS? Do you need HTTPS anymore? If the data is always encrypted end to end, it's only available to the workload when it's processing the data and it's protected, this protected enclave. A lot of the security needs essentially go away because even if a hacker gets root access or physical access to your system, they're not going to have any access to the data.